All right, welcome. Today, we're going to pull back the curtain on data mining. We're going to explore how data scientists use a really powerful tool called R to find secrets hidden in just massive amounts of information. And believe me, these are patterns that influence everything from your grocery store layout to what you watch online. So let's just dive right in.
So, to get us going, let me start with a simple question. What do potato chips and your favorite soda have in common? I mean, besides being a top-tier snack combination, of course. You might think, well, not much, but in the world of data, they actually share a very, very special relationship. And the answer is, they're often part of a hidden pattern. It turns out, decades of sales data have shown that people who buy chips are also super likely to grab a soda on the very same trip. Now, this isn't a coincidence, right? It's a data-driven discovery, and finding these kinds of connections is exactly what data mining is all about. So how do we actually find these hidden patterns? Well, the technique is called association mining, and it's basically the detective work of data science. It helps us find relationships between all sorts of different items in these huge databases. Let's break down the clues.
Okay, so the very first step is to find what data experts call a frequent item set. Now, this is just a fancy way of saying we look for groups of items that show up together, over and over and over again. Think of it like this. If thousands and thousands of shopping baskets contain both bread and milk, then bread-milk becomes a frequent item set, and that's something worth looking into.
But how frequent is frequent? I mean, what's the threshold? That's where a concept called support comes in. Support is just a number that tells us what percentage of all transactions contain our item set. So if 10% of all shopping baskets have both bread and milk, the support is 10%. High support tells us this isn't just some random fluke, it's a real, measurable trend.
Now, here's where it gets really interesting. It's when we can start making predictions, and that's where confidence comes into play. Confidence measures the probability that if a customer buys bread, they will also buy milk. A high confidence score means our rule, if bread, then milk, is super reliable.
Let's make this crystal clear with a super simple example. Okay, here we have 4 shopping baskets. To find the support for milk, bread, we just count how many baskets have both. We see them in basket 1 and we see them in basket 3. So that's 2 out of 4 total baskets, which means the support is 50%. It's really that simple at its core. This is the fundamental logic data miners use, is just scaled up across millions and millions of transactions.
Now, looking at tables is fine and all, but to really understand the deep connections between products, we need to start thinking visually. So the next big idea here is to stop seeing purchases as just lists and start seeing them as a whole network of relationships. Every single time someone checks out at a store, they're not just buying items, they're creating a data point. And that data point tells a story of connection. And when you have millions of these stories, you can start to draw a map of how everything is related.
And this slide gives us a fantastic visual for what that map looks like. It's a graph or a network. Each one of those dots could be a product, and the lines connecting them show how often they're bought together. It looks a whole lot like a social network, and that's really no accident. The very same principles apply.
A social network really has 3 key characteristics. First, you have your entities, so people on a social media site, or in our case, products in a store. Second, there's a relationship between them, like being friends or being purchased together. And third, and this part is absolutely crucial, the relationships aren't random, they cluster. Just like your friends are probably friends with each other, products that are bought with bread are often bought with each other too.
So we've got the concepts and we've got the visualization, but how does a computer actually do all this? How does it sift through millions of transactions to find these rules in a way that's actually efficient? Let's pop the hood and take a look at the engine that drives this whole process, using the programming language R.
Before we even look at a single line of code, the logic is actually pretty simple. It's a step-by-step process. First, the computer scans everything to find individual items that have high support. Then, it uses that list of common items to find common pairs. Which makes sense, right? If bread isn't popular by itself, a pair containing bread can't possibly be popular either. Finally, it takes these common pairs and generates those reliable if-then rules we've been talking about.
And that's all an algorithm is. It's not magic. It's just a set of instructions, like a recipe, that a computer follows to solve a problem in a really, really efficient way.
Okay, so let's look at how this is done in practice. This slide shows a little snippet of R code for a famous algorithm called a priori. Now, don't worry about understanding every single symbol here. The key takeaway is that this code is just that recipe we talked about, but it's written in a language the computer understands. You can even see words in there like rules and confidence that we've just defined.
This is how a data scientist automates the search for those hidden patterns, telling the machine exactly what thresholds to use for support and confidence to find the really meaningful stuff.
So here's the crucial point. Why do we do all this? I mean, finding these patterns is fascinating, for sure. But the real power comes when we use this knowledge to make decisions that actually change the real world.
And the applications are literally everywhere. That chips and soda pattern, that led supermarkets to place those items closer together to boost sales. The recommended for you section on Amazon, that's association mining. The movie suggestions on Netflix or the next video that pops up on YouTube, same exact principle. It's even used to detect fraud by finding weird, unusual patterns in credit card transactions. Of course, this is just the start. Data scientists have to be careful that these patterns are real and not just noise, but this core idea of finding associations is absolutely fundamental.
This quote from our source material really just sums it up perfectly. The goal isn't just to find any old pattern, but to find knowledge that is useful, valid, unexpected, and understandable. It's all about turning raw data into real, actionable insight.
So, the next time you get a recommendation that feels just spookily right, or you see two seemingly unrelated products placed right next to each other in a store, you'll know why. And it leaves me with one final question for you to think about. What hidden patterns are shaping your choices every single day? Thanks for joining me.